Hello everyone, this is Dr. Daya Sagar Chowdary, Senapati, Assistant Professor, Department of Electronics and Communication Engineering, Aditya University-Surampalem. Today we would like to discuss about the topic Programmable Logic Array. Simply we call this topic as a PLA. So coming to the learning outcomes, at the end of this lecture, student will be able to understand and the architecture and working of a programmable logic array, that is PLA, and how programmable and OR arrays implement Boolean functions. They will also be able to design combinational logic using PLA and evaluate its advantages, limitations and applications in digital systems. So coming to the PLAs were introduced in the early 1970s by Philips. PLA is a programmable logic device that has both programmable AND array and programmable OR array. Hence, it is the most flexible PLDs. A PLA is structured so that any of its input can be ANDed together in the AND plane. Each AND plane output can thus correspond to any product terms of the inputs. So here we can observe the block diagram, so which contains the programmable AND array and programmable OR array. So two block diagrams are there. Here array means, so it is a combination of, it is a collection of many AND gates, and here OR array means here a collection of OR gates. So here we are applying so n inputs and we are taking m outputs. So in between some outputs from the AND gate array, those are given to the inputs to the OR gate array. So here similarly each OR plane output can be configured to produce the logical sum of any of the AND plane outputs. So that means here in between some product terms are there. So we call that one as a min terms. So because of the min terms we can implement these min terms with the help of AND gates. So that is why we are using this AND array. So coming to the PLAs, so this is the circuit diagram. So circuit diagram contains the AND inverter circuits, AND gate array, OR gate array. So these are the three combinations here we are using. So inverters, AND gate and OR gate. So here most of the time we used the AND gate array and OR gate array. So inverter is for inverting the input. So here we are using this circuit. So this same representation, inverter representation is used here. So the same symbol we are using here. So the same symbol we are using in this particular combination. So one time we are using the same signal and one time we are inverting the same signal. So PLAs were well suited for implementing logic functions in sum of product forms. That means most of the time we are using SOP forms. So that is why this is fully applicable for implementing a circuit for the SOP form. They are also quite versatile since both the AND terms and OR terms can have many inputs. So we can use, because there is a flexible for this particular PLA, that means both AND gate is programmable and also OR gate is programmable. So that is why it is more suitable for designing the implementation of an equations. So these are the outputs of the AND gate and these are the outputs of the OR gate. At the end of the outputs of the OR gates, these are the functions. We call this one as a F1, F2, F3. So most of the questions contain these are the questions. So these are the output functions. Now programmable logic array. This is the simple circuit again. So all the inverter gate outputs are given to the AND gates. So AND gate inputs. So each AND gate contains the symbols, this S type of symbols. We call this one as a fuse. That means these fuses are already given in the circuit. So we call this one as a pre-installed or pre-defined circuit. So we are modifying this PLA according to our requirements. So this is a fuse. If we want to use this fuse, we can use this fuse, or otherwise we can blow out. That means we can simply damage this fuse with the help of giving some high power. So that is why PLAs are characterized by 3 numbers here. So anyway, n number of inputs, already we are defined n number of inputs, and p number of, that is, outputs are given to the AND gate inputs. So in between p is there, and finally the m number of outputs are we are getting. So here finally m number of outputs at the end of the OR gates. So these are the combinations of these 3 gates. So we are using in this particular PLAs. So finally the representation of the PLA is simple: n cross p cross m. This is the final representation of the PLA. Now coming to the, most of the time we will discuss about the problematic with the help of this PLAs. That means this is a predefined hardware. PLA is a predefined hardware. So according to our requirement, or according to our requirement means here this is the equation. So this is our requirement. So we have to implement this equation on the predefined hardware. So that means this is the hardware, predefined hardware. So we are implementing this equation on this particular hardware. So remaining we have to blow out the fuses, remaining fuses. So from that time onwards this PLA acts for the our requirement, that whatever our equation. So here A is implement the following Boolean functions using PLA. So A is one equation and B is other equation. Now A contains xy term, xz bar term. So that is why xy term. So the output of the AND gate inputs are x, y. So we are giving x and y, and the output is, this is xy term. And A also contains the xz bar. That means this is x and this is z bar combination. So AND gate, so which is given to AND gate, and finally we will get the output xz bar. This is the output of that AND gate. And B, second equation is B, contains xy bar. Again this is xy bar, and yz. So this is yz, and finally xz bar. That means this xz bar is already repeating. So this is xz bar is already repeating in both the equations. So we can simply neglect that xz bar again. So we can reuse this xz bar in our circuit. So that is the advantage of the PLA. So the given 2 functions are in the sum form, that means these are in SOP forms, and the number of product terms presented in the given Boolean functions A and B are 2 and 3 respectively. So we already know the 2 terms here, 3 terms here, and 1 product term xz bar is common in each function. So that is quite common. So requires 4 programmable AND gates and 2 programmable OR gates for producing those 2 functions. So this is the representation of this particular example. So contains 4 terms, because 5 terms, 1 term is common. So we can represent these 4 terms, and finally at the output our outputs are A and B. So at the output, that means after giving these inputs, the term inputs to the OR gate, we will get the output. That means OR gate output. So inputs are, so these 2 terms, whatever the xy, xz bar are the 2 terms for the A, and xy bar, yz and xz bar, these are the 3 terms. That is why we are connecting to this particular OR gate, and we will get the output B. So most of the time we are connecting with the help of this cross mark. So this cross mark is nothing but the fuse. So in order to represent the fuse, we are using this cross mark. That means here the cross mark is nothing but this is a fuse we are using. Here we are using one fuse, and that is programmable. So that is connected. So that is the concept of this particular PLA. Next, this is a second example. So implement the following function using PLA. Contains again 2 functions, F1 and F2. So F1 is simply one function, sigma m of 4, 5, 7, and F2 is equal to sigma m of 3, 5, 7. So this is a problem. Now we can implement these functions, these 2 functions. So F1, F2 by using, here already 3 inputs are there. So we can simply estimate. So first function is 4, 5, 7. That means 7 is the major one, and here also 7 is the major one. So we can implement from 0 to 7. So 7 is the major one, means we can expect 3 input variables. So likewise we have to take 3 input variables are A, B, C, but that means 7 can be implemented as 111. So from 0, 0 to 111. So this is the combination we have taken. That means inputs are already fixed, defined. Now F1 and F2. So wherever the function is there, that means F1 contains 4, 5, 7. So 4, 5, 7. So there we have to place 1 for the corresponding inputs. For this is the 4 combination, and this is the 5 binary combination, and this is the 7 binary combination. That is why we are placing ones in the F1. Again for F2, so 3, 5, 7. So 3, means this is the 3 combination. That is why we are placing 1 here, and 5 already 5 here, and 7 1 is placing here. So likewise we have to give, or we have to draw this table. So now again, so while drawing this table, simply we can use the K maps. So for this is for F1 K map, and this is for F2 K map. Simply we will get the whatever the optimized value, that is minimized value. So that is, we can group these two ones and these two ones. We will get the equation F1 is equal to AB bar plus AC, and for F2 also we have to produce one K map, and again for this one we have to group these two ones and these two ones. So F2 is equal to AC plus BC. These two are the equations we will get in the example 2. And implementation of this PLA with the help of this table, we call this one as the implementation table. So wherever the products are there, we have to implement. So finally we will get the 3 products, that is AB bar, AC, BC. So 3 products are there. So one is common term here. So anyway that common term we will represent here. So this is A. If it is A, we have to place 1 in place of A, because these are the inputs, and B is in 0 form, that means bar form. Bar form means that is 0, and C term is not there. That is why we are mentioning it as a dash. Likewise A is in normal form, that is 1, and there is no B term, so we can represent it with the dash, and C is there, again C. So 1 we have to draw, 1 we have to place 1 here in the C term. And likewise this is BC. So in this place, BC place 1 1 we have drawn, but there is no A. That is why we are simply using this dash. Now the outputs are F1 and F2. So wherever this term this term is in F1, so this term is in F1. That means AB bar, AC is these two terms are in F1. That is why we are placing ones here, and in F2 this AC and BC term are there. That is why we are placing 1 here. If the term is not there in F2, that means the first term AB bar is there in F1 but not there in F2, then we can simply represent it with dash. So likewise here also the dash is there. So likewise we have to construct this table for both inputs and outputs for a given example problem. And so if we represent F1 or F2 like this, we call this one as a T. T means true. So we can call this one as a true. If not, we can simply call this one as a C. That means complement. That means we can also implement this entire function with the help of F1 or F1 bar also. If F1 bar means that is complementation, that means complement means that is quite opposite, inversion of this particular function, and true means that is directly F1. So likewise we can simply construct our circuit. So simple again. So these inverters are again the same symbols we are using, and A, B, C are the inputs, and finally we will get the inputs for this particular AND gates, because these are 3 terms AB bar, AC and BC. So 3 terms again we are giving to this particular AND gates, and finally the output of these AND gates are given to the OR gates, because our functions are 2 functions F1 and F2. So one is from one OR gate, that is F1, other is from other OR gate, that is F2, and finally wherever the requirement, which term is there in the particular F1 and F2. So because of this particular purpose we are marking this one as a cross mark. That means OR gates are programmable here the cross marks are using, that means here AND gates are programmable. So that is why both AND gates and OR gates are programmable in this particular PLA. So likewise we can construct the circuit. So here we are using the cross mark. So cross marks are the connections, like these are the programmable. So this represents the programmable. That means AND gates are programmable. That is why we are using this cross marks, and OR gates are also programmable. That is why again we are using this cross marks, so that we can implement easily the entire functions for a given equation. So this is a example 2. Coming to the example 3, again the example 3 contains 3 functions. So we can implement n number of functions. That is the advantage of the particular PLA. So here there are 3 functions. Again the 3 functions we can simply represent with sigma 0, 1, 6, 7, 1, 2, 4, 6, 2, 6. This is the function. Again 7 is the maximum number. That means 3 variables are there. A, B, C we can take. So from 0, 0, 0 to 111, that is the 7 is the maximum. That is why 111 we can use the combination. So that is why the inputs are from 0, 0, 0 to 111, and F1 we can write. So that means in F1 0 is there. That is why F1, that is 1 we have to place for the corresponding inputs, and here one more 1 is we have placed it here corresponding input, that is 0, 0, 1, and for 6. So 6 also we have to place within the corresponding input, and in 7 is there. So here we have to place 1 for the corresponding input. So likewise again we have placed these ones under the F1. So likewise again we have to use the K-maps to solve this particular equations. So that means wherever the 1 is there, we have to use the ones particular place, 0 ones are placed, and we are grouping here, and finally we will solve this particular functions, and finally we will get an equation for F1, for F2, for F3. 3 equations we will get, and we have to take the common terms in these 3 equations. Finally we will use this again the table. So with the help of this table, again the product terms are 1, 2, 3, 4, 5. So 5 product terms are there. So common terms we can eliminate. So and the total terms are 5, and ABC again, if A term is there in bar, so we have to place 0. B term is there in that particular equation, that means B bar. B bar is there, we have to place 0, and C is there, directly we can use 1. So likewise 1, if the term is not there, we have to use the dash. So this is bar again, C bar is there. So likewise we have to give this table. Wherever in F1 this term is not there, that is why we are using this bar, and in F2 this term is there, that is why we are using 1, and in F3 this term is not there, that is why we are using the bar. So likewise we are using all this table, and finally we can mention this one as a truth. That means this entire circuit we have to design it for normal condition, that is true condition. So again we can implement with the help of these 3 inputs. So A, B, C. So again NOT gate we are implementing. So implementing means here A is given and A bar is also given. This is A bar, and this is A. Likewise B bar, B, C bar, C. So again we are using a bridge. So wherever here dot, not only the cross mark, if there is a dot also, that represents the programmable. That means connection is there. Connection is there means we can utilize this opportunity. That means this dot is also a connection. We call that one as a programmable in PLAs. So here dot is again there, dot is there for OR gates. That means again OR gates are programmable, and here dots are there, AND gates are programmable. So this type of structures we have to practice. So this is a simple implementation of this particular circuit. That means whatever the given equation, we can simply implement on the PLAs. So some major points. So in many logic design situations, not all the min terms are needed for a realization. So common terms are also there. So we can reduce the common terms. For n input variables, 2 to the power of n min terms. So wherever A, B, C are there, 2 to the power of, that is A, B, C means 3. So 2 to the power of 3 is equal to 8. So total 8 combinations. For 8 combinations, 8 AND gates are used. So that is the term, 8 min terms. PLAs with 16 input lines. If 16 input lines are there, definitely 2 to the power of 16, that is 65536 minterms we can use. In 16 into 48 into 8 PLA. So, this is the representation, means 16 inputs and 48 product terms and 8 outputs are there in this particular representation PLA. And 2n, we call this one as a 2n, that means the output of the AND gates are 2, that means that is one is true and the other one is complement. So, likewise we can take, so one is true, other one is complement. So, 2n inputs we can, so if n is the input, that means, so 2 into, if we take n is equal to 2, so 2 into 2, so total 4 inputs. So, likewise we can take. And coming to the advantages, so these PLAs are high flexibility, that means because it contains both AND and OR gates are programmable, that is why we can simply use this in so many equations. And efficient implementation, that means most of the multiple Boolean functions can share product terms, so we can share that product terms, common terms we can share. And reduce hardware, so minimizes gate count for SOP implementations. Custom logic design, suitable for implementing complex combinational circuits. Coming to the disadvantages, so higher cost compared to PROM, PAL. So, not only PLA, there are two more other terms, that is PROM, so programmable read-only memory, PAL, programmable array logic. So, when compared to these two, it contains the higher cost, because in PROM only OR gates are programmable but AND gates are fixed. In PAL, AND gates are programmable, OR gates are fixed, but in PLA both AND gates and OR gates are programmable. So, that is why this is higher cost when compared to this PROM and PAL. And slower speeds because of huge circuit, so that is why it is a slower when compared to others. So, due to programmable connections in both AND gate and OR gates are planes, that is why. Power consumption is also higher for large designs, because of the large design definitely power consumption is more. And complex programming and design compared to simpler PLDs. We can use this one for simple designs. If the design is more, definitely the complexity will be increased. That means complex programming and design compared to simpler PLDs. So, coming to the applications, these PLAs are used for custom combinational logic circuits and code converters and decoders and arithmetic and logic control units and digital system controllers and pattern detection and sequence control, embedded and communication systems. So, most of the time for code conversions we are using this PLAs. Also in digital systems and embedded systems used for communication part, mostly we are using these PLAs. Coming to the summary, so a PLA, simply called it as programmable logic array, is a versatile programmable logic device featuring programmable AND and OR arrays that efficiently implement combinational logic in SOP form. Its ability to share product terms enables flexible and compact realization of multiple logic functions. Although PLAs may be slower and more costly than simpler PLDs, they are widely used in digital systems requiring customized and efficient logic implementation. Thank you.